So chat कर दीजिए thermal animation. I want to talk to the audience to the second part from here, right? How do I talk to the audience? I want to talk to the audience. Yeah. Hello, can you hear me? Guys who are online, can you hear me?
Yes, sir.
Okay. So Ananya is a student, is it? And Akila is she also a student here? Okay. Hmm? Okay. All right. So yeah. Ananya, anything that happens, the thing is, we are also an online live classes are here. If you have any doubts, you can feel free to stop me and ask me in the middle, and then we will, I can draw something on the screen, I can click something, and maybe a better way. Okay?
Okay, sir.
Okay. So, good evening, everyone. Bhaskar, can you turn on this fan? So, my name is Planish Mukuba, and maybe you can come closer, I think. That's better. So, this one you can hear me. Okay. So, my name is Planish Mukuba. I'm a researcher here at IIT Madras. And I work in the areas of physics. I will be teaching physics for both of you guys. I mean, for the students are here. And so, Ananya, is it? What do you want to be, Ananya? So, what subject do you want to take?
I want to do something related to artificial intelligence. Sir.
Artificial intelligence, excellent. Wonderful. And what do you want to plan? I mean, in data science. Good. So, the thing is, Ananya and Ashwin. So, the thing is that after a certain point, right, everything gets very interdisciplinary. What I mean by that is that you will be doing coding in physics. I work in physics, but I code as well. We use artificial intelligence in physics as well. You may have to do a lot of mathematics in your computer science courses and so on and so forth. So things get very mixed up and everything starts looking alike really. To a point where there may not be a lot of difference between all of these fields. You know, that's what's happening right now. Everything is advancing so much, it's all starting to look very similar. Okay. I hope both of you are very comfortable with English. Okay.
Yes.
Yeah. So, Ananya, did you receive any textbook or any book that they have given you for the syllabus or anything?
Can you repeat?
Hmm?
Can you repeat the question?
Yeah. Did you receive any book that these people have given you? Have they given
No, no, I didn't.
you? Hmm?
No, I didn't.
Okay. And have you gotten any book? A textbook you have gotten. Okay. And then maybe you can follow up with these people and ask them if there is a textbook or something that they can give you. Okay. Because that is the book from where I will be covering things. Okay.
Okay.
Yeah. So firstly, we are going to talk about this chapter, which firstly will start with something that is slightly maybe more challenging. So that you may be able to appreciate things in a different way, maybe a better way. So the chapter is called thermal properties of matter. Okay. Or in our world, in the world of engineers and physicists, we say thermodynamics. You know, the word is, we use the word, I'm not sure why this. Okay. Yeah. We use the word thermodynamics. Okay. Thermo means temperature. That's where our word for thermometer comes. Thermal, right? Even our flask, we call it a thermos flask. So what is the meaning of thermal? Thermal, it means temperature. Dynamics means the study of its movement or its motion or things like that. To study. So thermodynamics is basically the study of temperature. Okay. And that is very important. And Ananya and Ashwin, I would prefer that, unless I tell you, it's not necessary to take notes. If you have a book for reference, that's always good. Some equations we will note down when as and when required, so that you can solve some problems. Okay. So Ananya and Ashwin, I want to make something very clear that my job here is to clear out the concepts of things. Okay, are you getting it?
Yes.
So when there is some concept, I will do my best to make it as clear, as beautiful, as understandable as possible. When it comes to solving problems and things of that sort, studying for exams, that's your responsibility. My job here is to open your eyes so you see those things, you understand what it is. Okay? Now, but the thing about my teaching is I will equip you enough and more so that you will be able to do things by yourself. Okay? In fact, there have been times the students are doing after the teaching, they didn't even want to have to read the textbook because they've understood things very clearly. Okay? So just listen properly. Okay? So first of all, see, why should we study this subject called thermodynamics? Why should we look at the thermal properties of matter? So now when we are looking at any kind of system, we may have a car or we have a monkey. One of the very common things that is going to be change the temperature. You may see that when you have what you have a laptop, your laptop or your computer has a fan. Why does it have a fan? To let it be correct. So because the computer itself is producing when it's running, and you want to reach that. Okay, it again reduces heat. So it is very important to study because if we can do it properly, we can use it for what is you know the light which comes in the sun, we can convert, we can do a lot of smart, interesting things with temperature. We can create a lot of beautiful inventions like your, you might have a microwave at home, you may have a fridge at home, you may have an AC, even imagine that it is possible that you can put something below the surface. People would have gone crazy if it was an but I can read one book 15 degrees. This is before. So that is the beauty of it. Okay, and this is some of the most advanced, this is some of the most, one of the most in demand fields. If you want to go into nuclear physics, if you want to go into particle physics, if you want to go into, you must have heard about nuclear reactors, fusion, things like that. So very, very big things are happening. In fact, even if you want to study astrophysics, you want to study the stars, the sun, you will need to study mathematics. Okay. So firstly, we start with defining these things, and we start with the word temperature. Can anybody tell me what temperature is? Wait, I'll ask the online student. I'm not sure about the name. Is it? Ananya?
Yes, sir.
Can you tell me what temperature is?
Temperature is like used to measure if an object is hot or cold.
Correct. So temperature is nothing but it is the degree. It is the degree of hotness or coldness of one object. Okay. You don't need to write all these things down. You can refer the textbook. Some information to write it down. You listen to the problem. Okay, that's enough. If you have the textbook, you can refer it later on. Everything will be okay. Okay. So temperature is what? It is the degree of what? Hotness or coldness of a body. Okay, and that is called temperature. And based on this, we can know where the heat is actually flowing. Okay. So the interesting thing about temperature is temperature will always go from one hot object, it will flow towards cold object. Are you getting it? Cold will never come to hot. hot will go to cold. It is the other way. Okay. So if I have a room here, this is my room. Okay. And it's quite hot. This is a hot room. And I want to cool it. What I will do? I will not provide cold. It is not possible to create cold. Understand? But it is possible to remove heat. Okay. So what are AC and some of refrigerators? What it is, they don't give cold. It is not possible to create coolness, but it is possible to remove heat. Okay, is that clear, Ananya?
Yes, sir.
Okay. So what I'll do is I have a room. I'll connect something on here, which is in a relatively lower temperature. Maybe it's slightly cold. So the heat from this room will flow to the colder object. Maybe I'll connect another thing like that, and then it will open in the air. So the heat will go to the air, to the surrounding. And this process will keep continuing until this hot room also becomes a cold room. Are we clear? And the SI unit, so the thing is, see, everything that we measure, any measurable quantity, it will have a SI unit. Meaning, now if you want to measure distance, you cannot tell, oh, I am 1 away. You have to tell 1 kilometer away from you, or 1 meter away. So you have to define any kind of a measurable quantity. And the SI unit for temperature, no. So the SI unit for temperature is called Kelvin. Okay. Are you getting this for the first time? Yeah, okay. So Kelvin is the SI unit of temperature. But we use Celsius, Fahrenheit, and things like that in our discussions, and that is the way to, but scientifically we use Kelvin. Okay. So there's another concept which is called heat. What is heat? Heat and temperature are two different things. Temperature is the amount of hotness or coldness of the body. Heat is a form of energy, which can flow from one body to another, or it can flow to the surroundings because of temperature. Okay. Now, when we have something which is very hot, we need something which is very cold. What will transfer from here to there? Heat will transfer. Okay, heat is energy, and this heat also has an SI unit. Okay, SI stands for Standard International. Okay, international or international standard. Okay, of units. So it is called Joule. Okay, there is another unit for heat which is called calorie. And how do you define this calorie? One calorie is defined as the amount of heat that is required to increase the temperature of 1 gram of water by 1 degree Celsius. If you want to know, you can do it. Otherwise, it's one of the things you can keep at the back of your head. Okay, but the main thing is our Joule calorie. Okay. So, yeah. So, Ananya, do you know what a thermometer is?
What?
Do you know what is a thermometer?
Yes, sir. It is a device that is used for measuring the temperature.
Okay, it is a device which is used to measure a temperature. So, how do you build a thermometer, Ananya? What do you think? If I want to create that, how do I create one? You can tell me anything. There is no wrong answer. It's okay to be wrong.
Are you asking how to build a thermometer?
How to what?
How to build a thermometer?
No, how to create a thermometer. I want to make one.
If, for example, if you want to see how hot an object is, then we can actually keep a metal rod on the thing that we want to measure, then if it turns hot, then it is actually, then we understand that it is a hot object.
Okay, cool. But the thing is now, if I want to create one thermometer, let's say I have nothing with it, okay, and I want to make one thermometer. So what I do is I take one kind of a material. Usually, have you seen the mercury inside a thermometer? Right? There is silver color thing or a red color thing inside the thermometer. So the thing about that material is when heat is expanding, when heat is given, it will expand. It will become very, it will expand in size. So what I do is now let's say I take one rod, okay, and I'm going to make one column inside this rod, and in this column I'm going to fill this thing called mercury, and at the end I'm going to put one metal tip, okay. But now I don't know how to measure this. So what I do is I simply tell, I will take some water. I'll take some water which is turning into, okay, simply it is turning into ice. I'll put it over there. Okay, the mercury might be at this level. It will come down. It will come. Okay, it's cold. So I will simply tell, let this be my zero. So my reference is what? At this zero, what is this? That is my reference. I take the same term and I put it in board. And it is looking from my going to this expanding because and the mercury is going up. Then it is that. And then okay, I call it. And in between 0 to 100, I divide it into equal. So this is how they made something called the Celsius scale. Okay, and that's how what our thermometers are not follow. The lower fixed point is 0. That is where the water becomes ice. The upper fixed point is 100 degrees Celsius. That's the boiling. Is that clear? And the number of divisions that are in between, it is called. We have 100 number of divisions, like your scale, 100 divisions. Now there was another fellow who said, you know what, my lower fixed point is going to be, I'm going to save the same material. But where the water becomes ice, I'm going to call it 32. And he said, okay, so the maximum I'm going to call it 212. This fellow became known as heat. Okay. And you may wonder why they're making so many. Maybe one person in 100, 200 years ago, he made apparently very popular. So when people that's it. And the interesting thing is there is a way, okay, there is a third one. Talk about it. And this is the most interesting one and the best one. The third one is called Kelvin. Okay. It was developed by this guy called Lord Kelvin, a British fellow. And the lower fixed point is 0 Kelvin only. That is the lowest. But this, if you take in degrees Celsius, it will be minus 273.15 Celsius. It means 0 Kelvin is in our Celsius scale, it is minus 273.15 degrees Celsius. Very, very cold. Okay. In fact, I think this amount of cold we cannot reach. Okay, it's very, very cold. And the upper fixed point is 100 Kelvin, which is nothing but, no, I don't think there should be this upper fixed point. Okay, but whatever. Okay, you just need to remember this part. Okay, fine. So there is one way that you can convert from Celsius to Fahrenheit, from Fahrenheit to Kelvin, and Kelvin to Celsius. Okay, the simple funda is this: C by 100 is equal to f minus 32 by 180 is equal to Kelvin minus 273.15 divided by 100. See, with Kelvin, it's very easy. Kelvin and Celsius. So any value, if it is 30, if you want to know, that's all. You got it. Kelvin. Okay. But with Fahrenheit, it is slightly different. So if we take this part and I simplify this, okay, let's see if I'm understanding. Okay, so I can, okay, that is fine. So what are the things? They are not doing this fine. Okay, but remember this, okay? C by 100 is equal to F minus 32 by 180. This is your simple funda. Okay? Is that good? Or what you can do is, if you have C for value, you can take this to the other side, minus 32 into 10 by 18. When you take 100 to the other side, 0, 0, you can cancel it. That's all. Okay? If you have using this formula, if you have the value in Celsius, you can convert to Fahrenheit. If you have value in Fahrenheit, convert to Celsius. Very good. Very good. If I take this part, this one and this one, right? What is it? C by 100 is equal to 273.15 divided by 100. This 100 number to the factors with the denominator share will be very direct. C minus 273.15. Or if I want to know what is my Kelvin, C plus 273.15. Okay, that means if I know the value of Celsius, if I want to know Kelvin, then in fact it's a very direct thing. Okay, so using this, can we now solve one problem? Can you note it down now? Can both of you note it down? Ananya, are you here?
Yes, sir. I'm noting it down.
Have you understood this so far?
Yes.
Okay, can you write down these formulae? Maybe? Write
Yeah,
down.
I'm writing it down.
Okay, okay. Okay. Okay, just note it down and then I'll give you one problem to solve. Okay, it's a very simple. Just write down the equation. Maybe I can take you back by one page. Right? Is that okay? Yeah, Ananya, can you hear me?
Yeah, I can hear you, sir.
Okay, in the middle you couldn't, I think, right?
Yeah.
Okay, so if you're noting down the equations, I want to know the problem. Okay, the problem says the norm. What? Yeah, this is it. So from this one we can solve the list. This is equal to this. This is equal to this. Okay. So yeah, the problem is this. Note down. The normal temperature of the human body, the normal temperature of human body is 98.4 degrees Fahrenheit. Human body is 98.4 degrees Fahrenheit. Convert it into Celsius scale. Okay. Ananya, did you get the question?
Yes, sir.
Yeah. So based on these equations, it's a very straightforward substitution. And in the solve it and get we solve this. Hello. Can you convert it into Kelvin? Take from Celsius and convert it into Kelvin. Hello, Ananya.
I'm doing it, sir. Give me a minute.
Okay. No problem.
So I'm getting the answer as 310 Kelvin.
Okay, and did you do it in Fahrenheit, in Celsius?
Celsius, I'm yet to do it once again.
Oh. So this formula can directly use it. Very directly. Using those answers. We have a minus 32 to 10 by you put our value that means that 4 minus 32 to 10 by 15. If you solve this,
Sir, I got 36.8.
yeah, it comes about 36.9. Okay, but correct. Good. Okay. And for Celsius, to Kelvin, you just add which is actually 73.15. Okay. All right. Is this much clear to you guys? Okay. Yeah. So I'll move ahead. Okay. So now what we're going to do is we are going to look into something called ideal gas equation. Ideal gas equation. Okay. Ideal gas equation. Okay, and this is one of the most beautiful, one of the most important equations in thermodynamics. And the strange thing is, it is a combination of three different laws discovered by three different during three different times. Okay. Ananya, can you hear me? I'm so sorry. Okay, I keep calling your name because I don't know if you can hear me, you cannot, and things like that. Okay.
I can hear you, sir.
So the first one is called Boyle's law. Okay. So this law was discovered by, I forgot his first name, Sir Boyle. Okay. And this is the guy who was Irish. So he was an Ireland. And he discovered it in around 1660. Okay. So what this guy discovered was that pressure is inversely proportional to volume if the temperature is constant. You can know this stuff. Okay. As I'm doing this, you can move this down. Alright. So pressure is inversely proportional to volume at constant temperature. What that means is if I increase the pressure of the volume and the temperature must remain constant. Okay. So then there was a second guy whose name was Charles. And there's a law that he found which is the last. It's called Charles' law. Now this Charles the law, he was French. This is not important, but I just want to show you. These dates and all are not important. The only reason I'm telling you this is because you have to understand see. This is how science works. The first guy was in Ireland and he discovered this in 1660. The second guy is in France. He discovered it in 1780. It's a different time in a different country. Okay? And this guy discovered that if he increased the volume of, let's say, if he takes some water and he increased its volume, the temperature also increases. Or you can say the other way. That means if I take some water or if I take some ice, let's say, and correct? Can you imagine this? Are you able to get this? So the only condition asked here is that the pressure has to be constant. Okay? All right? Okay. Now the third fellow, this guy's name is avocado. Have you heard this word before? Have you heard avocado? Yeah, avocado. Same fellow, same guy. What he found, and this guy is Italian. So this is the beauty of science. One guy, three people from three different countries, and this guy did it in around 1812. Three different centuries. They found three different things. And these three different things came together form the ideal classification. Okay. So before we talk about ideal classification, we want to look at what Avogadro means. He found something very simple, but something very important. He said, if I increase the volume of a material, the number of moles in that material will increase. Okay. What is a mole? Does anybody know? Okay. Okay. And he said this is only possible if the pressure and temperature, both of them are constant. Okay. Ananya, are you available? Are you aware of Avogadro's number?
Yes, sir.
Okay. So Avogadro number is nothing but it is a number. Okay. This may be one dozen. Instead of saying 12, correct? Instead of saying I want 12 of something, I say I want 1 dozen. In the same way, we say I have one Avogadro, one mole. One Avogadro number is 1n, or it's called 1 mole. Yeah, denoted by the small n. So I have 1 mole of atoms. If I have 1 mole of, let's say, molecules, that means that in 1 mole, there are, you know what the number is? 6 into 10 to the power 20. Okay. Same like normally 1 into the power 12. 1 mole of a molecule is 6 into 10 to the power 20. Small. If I have 1 mole of particle, that means 1 6 into 10 to the power 20. Understand? Okay, and this is common. If I increase the volume of something, obviously the number of moles are going to increase. So the number of material increase. Correct? If I tell the volume of banana is going to increase, that means the number of dozens of banana will increase. That's all. Right. So now 3 different laws, they were thrown together to form what we call the ideal gas equation, and one of the most important and beautiful equations in all of physics. It is given by PV is equal to nRT. Okay, it follows all of these previous laws. Okay, P is inversely proportional. We see that P is inversely proportional to V, P is directly proportional to T, V is directly proportional to T, V is directly proportional to N. All of these are coming together. Understood? And what is this R? What we do is here we have a constant. Okay, do you know guys know what constants are? Okay, okay, I'll tell you. So this is it's called the ideal gas. It's called the ideal gas constant. Okay, you know what the gas constant. R is called the universal gas constant. Okay. Note this down, and its value is 8.31 joule per mole per Kelvin. Okay. So what is the meaning of this constant?
So could you write down what each of the letters mean?
Yeah. So P stands for pressure. Okay. V stands for volume. T obviously stands for temperature. Okay. And this N stands for number of moles. Okay. Is that clear? Yeah. So the value of R is value is given by 8.31 joule per mole per Kelvin. That is the SI unit. Okay. divided by Joule, J, per mole inverse. But inverse is right. You know that? MOL, mole, sorry, MOL, okay, MOL mole per Kelvin K. Mole inverse K. Is this clear to you, Ananya? Do you have any doubt on here?
No, I don't.
Okay. So have you understood this much? Can we proceed now? Okay. So yeah. Okay, so this is our ideal gas equation. So now the thing about constants is these are combined in common picture. Now if I tell you that P is inversely proportional to V, it does not mean that P is equal to 1 by V. No, no, no. There are two different things. The meaning is that if P decreases, P actually 1 by V decreases, and because of that it increases. Okay, but let's just say V will increase. Okay. But this means that if both are equal, means it does not tell me, see this, the first one, it does not tell me by how much it increases or decreases. It is only telling me that yeah, that's a big point. But we don't know the value of the one that of the table. So what is there is a movement equal to sign. There is one constant, let's say C or something like that, which is good, which will be a multiplicative factor. So it will adjust to the value that it will make it equal. Are we clear about that? In fact, there is one very nice example to understand constants. And we will do this when we are talking about the next topic called thermal expansion. At the time, you will understand these constant things better. Okay. So now, what is the interesting thing is now we saw from Charles' law that V is directly proportional to T. Okay. So if now I reduce the temperature so much, very much, what will happen? I keep on decreasing the temperature. What is going to happen to volume? It's directly. Okay, keep on decreasing. So there will come a time where you have decreased so much that the temperature has gone to zero, the volume has gone to zero. Okay. Then now we know from our Boyle's law, P is inversely proportional. So V keeps on decreasing now, just becomes zero. What will happen to P? P actually should increase in parallel. But this the condition for Boyle's law is that it should happen at constant temperature. That is not the case. The temperature is also dropped here. The temperature is dropping in this situation. So eventually, what we actually experience is that there is a situation wherein the pressure also becomes zero. Our volume also becomes zero. Okay. And at this particular moment, can you imagine this in your head? You know, you take one, you decrease or increase that. You have got a situation where the pressure is zero. So at this moment, if you look into the app, you notice that the mole stops moving on. This situation is imaginary, and at this point, the temperature which exists is called absolute temperature. Okay, and this value is nothing but what is this temperature? the value of this is minus 2 minus 3.16 degrees Celsius. This is where you get your time from. Okay, understood? So this is taken as the absolute zero on the same scale. Okay, it starts on this value, and that's why anything if you want to convert to Kelvin, you add this. This is a zero plus whatever is Celsius. You get it clear? Okay. So are we clear with this one? Ananya, are you clear with this?
Yes, sir.
Okay. If you have any doubt, you can always stop me and you can ask me. Okay. All right. So having known this, and if we know this equation EV is equal to nRT, we can actually solve one particular problem. Generally, can we solve one problem? Okay, can you note it down? I tell you the equations later. Okay. So it's very simple. The pressure and temperature of a gas are 2 atm, 2 atmosphere. That is the SI. 2 atm. Yeah. So it's called 2 atmosphere. 2 atmosphere. 2 atm. This is the pressure. Okay. And our temperature is 27 degrees Celsius. Okay. So the question is A, I'll write that as A. Find the number of moles per centimeter cube and B, find the number of molecules per centimeter per meter cube. Is that okay? Okay, now the situation here is that first, before you start solving this problem, I want to tell you that the pressure is given ADM, it stands for atmosphere, 1 atmosphere to atmosphere. And that is not that is and then we always try to fix the value. And the entire pressure is Pascal. So this has to be converted to Pascal, and the process is very simple. Whatever it is, okay. So this will be nothing but 2 into 10 to the power of 5. Okay. So using this information, can we solve the problem? Do you know an equation that can maybe do it for you? We solve it using EV is equal to nRT. Okay, can we do this? We have the value of P. You have the value of your temperature, and temperature is value. What is the value of the temperature? It is in Celsius. Is Celsius or SI unit? Celsius is not SI unit. So convert the temperature from Celsius to Kelvin, and then put that value for that. Okay. P is going to be the volume, but we do not have the volume, right? So let it be. To substitute everything. Temperature, have you converted into Kelvin? It is 23 degrees Celsius plus 293.15. We just round it off at 300. Okay, just the simplicity. 300 Kelvin. So So we know the pressure. Pressure is 2 into 10 power 5. We do not know, and also we do not know. But what we have to find? What do we have to find? No, what have they asked? Moles per centimeter. R is a constant, R is a value. Then it is what? Okay. It is that. Actually, it was 1, but to simplify. So what we get is n by v we can take on one side. What we want? Number of moles per centimeter cube. That is what we are getting here. N by v. N by v is volume centimeter cube. Okay. It will actually be meter cube. No, centimeter. Correct. It is v per meter cube because that is the size. So what we get? One side to 10 to the power of 5. Three point three into 300. Yeah. Some value you will get. This value is your number of moles per meter cube. Okay. Now you have to find, but they have asked you number of moles per centimeter cube, right? So in 1 meter, how many centimeters are there? 100. So it's cube, right? So if you are going to divide this by 100 3 times. Meter cube 100 into 100 into 100. So you divide that value. You divide it by 10 to the power of 6. That is your moles per centimeter. Simple. So yeah, this value what is it? Let's solve it. Then you going to divide it by 10 to the power of 6. Will there are moles per centimeter cube? That's all. And the next question is number of molecules meter cube. So now we told you, right? In 1 mole, how many molecules will be there? So you simply multiply this value into that and you got down. See, but they have a per meter cube or centimeter cube, they have molecules per. No, they have the second question. See, number of moles per. Okay, the question is for meter cube. I made a mistake by typing it. It's meter cube. Okay. So you're going to take which answer? You're going to take this answer and you're going to multiply it into your Avogadro number. Yeah, that's all. Okay. Very simple. Are we clear with this much? Ananya, are you clear?
Yes, sir.
Okay. So if you feel that it would be and you will understand it for sure. Okay. Yeah. So next, there is, so the thing is, see, in your 11th period syllabus, when you get this together, in one of the will be probably then you and after must have been very yeah. So maybe for 1 week they'll take one chapter, but last year like that you are very fast and you have to be able to solve it immediately. Okay, fine. So we'll do one last kind of sub-topic or topic in this unit. So it's called thermal expansion. Okay, thermal expansion. So So do you know what thermal expansion is? Ananya, any clue what thermal expansion?
No, sir.
Okay, that's fine. So thermal expansion is, see, under the presence of heat or any kind of thermal energy, a body will expand. That's all. That's a thermal expansion. Under the influence of any kind of a temperature, there's going to be expansions. You must have seen, no? If ice is there, if you provide heat water, it will expand, it will become water. Okay. If you heat it more, it will become gas, then that takes more volume, becomes more expanded. You know, the molecules get far away, they will spread only the gas. Okay. So, but what is this thermal expansion and what is this coefficient of thermal expansion? So let me try to teach you this with the help of an example. Please forgive my handwriting. Okay. Yeah. So let's say I have one boy. What do we call it? Call him Chotu. Okay. Fine. And I have another person. We will call him Apartment. Okay. So this is Ram. And this is the third person. Name him Lakshman. Okay. So we have Chotu, we have Ram, and we have Lakshman. Okay. So all of these people, I'm going to give them 10 kg food for 1 week. Okay. Do you think all of them will gain the same amount of weight? No. Because everybody's body is different. Right? So you may eat less food, but you will eat more food. Everybody's body is different. So what I'm going to do is I'm going to give 10 kg food to all of these people. Okay? And the interesting thing is now that Chotu has gained, he has eaten this. Okay? And Chotu has gained 5 kgs. Let's say. Okay? This is just he has gained 5 kgs. Ram has gained 7.5 kgs. Understanding? And Lakshman has gained all the kgs. Okay? So what will happen is, I cannot say that everybody eating the same food will gain the same amount of weight because their body is different. Correct? Similarly, any object under the influence of heat will expand differently depending on the material object. Ice will expand differently, steel will expand differently, gold will expand differently, wood may expand differently. Any kind of material, they will not behave the same, they will not behave the same on the same of heat. If I put 10 degrees Celsius of heat, this may expand more, this may expand less, you know. So there is one value that I can give to this kind of material that is called coefficient. Okay, coefficient of thermal expansion. For example, in this case, I can say Chotu gain 5 kgs by eating 10 kgs of food multiplied into one coefficient into A. And if I solve this, what will I get? E is equal to 5 by 10, which will be 0.5. So Chotu's coefficient is what? Eating coefficient is 0.5. Meaning for every 10 kg, okay. If I do the similar for Ram, yeah, it will not be the same. Okay, it will not be the same. The value will be different. It will be 0.75. If I do it just for Lakshman, his coefficient will be 1. Meaning whatever he eats is gaining. Okay? So for Ram it is different, for Chotu it is different. Similarly, we have the same concept for thermal expansion, which means it will tell us how much an object will expand for a certain heat which is given. Okay, and how do you define this coefficient of thermal expansion? So it's called the coefficient of okay, how do I define this? It's the ratio of the change in dimension divided by the initial dimension multiplied into the increase in temperature. Okay. That's right. Here, Anya, are you able to understand this?
Yes, sir, I'm noting it down.
Yeah, but have you understood it?
Yeah, I understood.
Okay. Yeah. Okay. Yeah. Have your classes started offline? Really? For how long have you been doing anything? Means you are learning school. 10th standard. Lab. You are finishing your lab. No, there's no class. No, you said anything. School is anything. And then you are getting okay. So you have a mission. Ananya, give me a moment, okay? There is study.
What, sir?
Just give me 2 minutes, okay? I'll continue. They're just setting something up.
Okay.
Okay. Okay. Yeah. All right. So the coefficient of thermal expansion is what? The change. It is defined as the ratio of the change in direction divided by initial value. The change in dimension means what? If it was 5 centimeters, it became 10 centimeters. Change in dimension is what? 10 centimeters minus 5 centimeters. 5 centimeters is change. So what will be the initial dimension? It was 5 centimeters. So that is the initial dimension. Increase in temperature, meaning how much temperature are given? But then degree Celsius. That's all. Very simple. Okay. So similarly, they have defined this for 3 different. Okay. There is linear expansion, there is superficial expansion, and there's cubical expansion, but it's the same thing. They're just simply chumma they have, simply they have made it. Okay. So what is this linear expansion? Linear means in one dimension. Okay, meaning length, height. That's all. That's one dimension. Okay. So this here our coefficient of expansion is done by alpha. Okay. So what did we say? It is coefficient is defined as what? The change in length it will be, correct? So it will be delta L, change in length means L2 minus L1. Okay, no? Divided by initial length. So it will be L1 into increase in temperature, delta T. Delta is nothing but change, okay? Delta don't get confused by all this delta. Delta means change, meaning it will be T2 minus T1. Okay, or let me write it in that way. So it will be L2 minus L1 divided by L1 into T2 minus T1. Change in temperature. Okay. Similarly, this is for linear length. Now I have for superficial. Superficial means what? It means that there is a two-dimensional change. Two-dimensional change means there is a change in area. Okay, surface area. Okay, so this is given by beta, coefficient of superficial expansion. And what will this be? Similar change in what? This was length, that was two dimension. This is going to be what? Length was one dimension. Superficial what? Two dimension. It will be surface area or area, or I can just say delta A by H1 delta T. That's all. Meaning which is the final area means initial. Yeah. Divided by initial. Yeah. It is the change in temperature. That's all. Okay. The final is cubical expansion. Cubical means what is the three dimension. If you're falling, it is not only your length, but along with it. So this is given by here. And what will this be? Similar. Volume. So delta V volume V1 delta T. So this will be V2 minus V1 by 1. Okay, that's all. Okay. So these are our three coefficients of expansion. Okay. And this can be further simplified also. Okay. Yeah, that's this is not B, this is like down. Okay. It is down. Okay, can you note this down, everyone? Okay, just note it down and then we'll find it. Ananya, start?
Yes.
Okay. Okay, then for today we'll wind up and we'll continue tomorrow. Okay. I hope Ananya, have you understood what we discussed today?
Yes, sir. It was clear.
Yeah. Was the teaching fine?
Yeah.
Okay. So any complaints or any queries or anything I should change?
No, 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 sir. It was clear.
It was clear, no? Okay. Because
Yeah.
it's, I don't know if I'm able to convince you about things or not. Okay. It was fine, no then?
Yes, sir. It was clear.
Okay. Okay then. Chalo. See you tomorrow.
Bye,
So
sir.
we'll go through these things today, okay? Because otherwise tomorrow we are going to understand 10 more concepts like that. It's going to be
Oh,
training if you don't go through it and understand today. Tomorrow you may get confused then. Okay?
okay, sir.
You should learn these things today, try to go through it because it is fresh in your mind. Tomorrow when we continue, you'll understand everything again. Okay?
Yeah. Sure, sir.
Okay, bye.
Bye. Thank you, sir.
Yeah, no problem. Everything fine, okay. So, how easy is right? So, your school is this started this time. They started no,